Right, we're moving on to more advanced calculations of amounts in lesson 9b, where we're going to do mass calculations. When given the mass of one of the reactants, calculate the unknown masses of any of the other reagents. So our first example is to calculate the mass of magnesium oxide formed when 10 grams of magnesium burns in enough air. The first thing is to write a balanced equation. So magnesium is going to react with the oxygen in the air to make magnesium oxide. And to balance the equation, I need 2 oxygens on both sides of the arrow, and we need 2 magnesiums on both sides of the arrow. So the mole ratio is 2 moles to 1 mole to 2 moles. And of importance in this question is that they've given us the mass of magnesium, and they want the mass of magnesium oxide formed. So the ratio is 2 to 2, which is the same as 1 to 1. Then we go to what they have given and what they have asked. So they give us 10 grams of magnesium and they ask us the mass of the magnesium oxide. To change the grams into moles, we need to say mole is mass over molar mass, so it would be 10. Now the molar mass of magnesium on the periodic table is 24. So 10 divided by 24 is 0.416666, so I'm going to say 0.42 moles. Now the mole ratio is 1 to 1, or you could say 2 to 2, which is the same as 1 to 1. So the moles of magnesium oxide that will be formed is 0.42. To change that into mass, it's moles times molar mass, so it's 0.42, and the molar mass of magnesium oxide you find by adding 24 to 16, and that gives you 40 times. This is, now I did not round my calculator answer to 0.42, I used 0.416666, and we get 16.67 grams. Next one, we use urea, and they give us the formula there. It is prepared in the fertilizer industry. It is a common source of nitrogen used for the growth of plants. What mass of ammonia must be used to prepare 1 kilogram of urea according to the following unbalanced equation? I must have changed it because now it is a balanced equation. So 1 mole, what are we interested in? There are quite a number of. We are interested in the ammonia, so it's 2 moles ammonia gives us 1 mole of urea. And that's what I'm going to need to work with in this question. So they say 1 kilogram of urea is formed, so that's 1,000 grams. And they want us to calculate the mass of ammonia. So the 1,000 grams must be changed to moles by taking the mass and dividing it by the molar mass. So the mass is 1,000, and the molar mass is, there are 2 nitrogens, so it's 2 times 14. There are 4 hydrogens, so it's 4. There is a carbon, that is 12, and an oxygen, that is 16. So this is 1,000 divided by, I haven't added these, 28 plus 32. I hope I'm not making a mistake. So this is 16.67 mole. Once again, I'm not rounding my answer on the calculator. I'm keeping it like that. Now, the mole ratio here is 1 to 2. So to change it to the moles of ammonia, I need to double up on the 16.67. So I must double up on that, and I get 33.33 moles of ammonia. So the mass of ammonia that is required is 33.33 times, and the molar mass of ammonia is 14 plus 3, which is 17. So multiply by 17 and we get 566.67 grams. Good. In the next one, question 3, the reaction between hydrochloric acid and zinc is used in the preparation of hydrogen gas. Calculate the volume of a 0.5 mole per cubic decimeter solution of hydrochloric acid needed to react with 10 grams of zinc. Now this is not a gas volume, this is a concentration volume. So let's first start with our balanced equation. Zn plus HCl goes to ZnCl2 and H2. To balance the equation, I need 2 moles of hydrochloric acid. So 1 mole of zinc needs 2 moles of hydrochloric acid to give us 1 mole of zinc chloride and 1 mole of hydrogen. So they want us to calculate the volume of hydrochloric acid to react with 10 grams of zinc. So whatever they give us, change it to moles. Moles is mass over molar mass. Woo. Yeah. My dog just came to give me a fright. So it's 10 grams, and the molar mass of zinc is 65. So 10 divided by 65 is 0.15 moles. Now this requires double the amount of hydrochloric acid. So I need to multiply these with 2, and you will get, I did not round my answer, I'm just using it as it is on the calculator. So it's 0.30769. So I'm going to say 0.31 moles. I can't penalize you if you use 0.15 and you multiply it by 2 to get 0.3. So if this is the moles of HCl, they've given us the concentration as 0.5 mole per cubic decimeter. So what volume of HCl do we need? Now concentration is mole divided by volume. So the volume would be the mole divided by concentration. Some simple mathematics for you to sort out. So it's 0.31 divided by 0.5. So 0.31 divided by 0.5 and you get 0.62 cubic decimeters. Right, nice and challenging. I hope you enjoyed watching.